My name is Olabi Emmanuel, your mathematics teacher, and I'll be taking you the topic cycle theorem. Cycle theorem. And at the end of this topic, you should be able to identify and solve problems in relation to angle at the center and angle at the circumference. Secondly, you should be able to identify and solve angles in the same segment. And thirdly, you should be able to identify and solve angles in a semicircle. To begin, let's recall. Let's look at what cycle is. Cycle is a locus of a point or all points equidistant from a particular point called center, which is the center of the circle. Now, cycle theorem. Cycle theorem is all facts about angles or length in a particular situation, all involving cycle. It is also to explore interacting properties of a cycle, which include the center, diameter, radius, chord, arc, and so on. Now, going back to our objective, we want to look at the angle at the center and the angle at the circumference. Now, from the diagram, we have two diagrams. Observe the diagram. This is A and this is B. Now, the theorem states that an angle at the center is twice the angle at the circumference. It states that an angle at the center is twice the angle at the circumference. From the diagrams above, we want to illustrate this theorem. Now, looking at the diagram, we have ACB, angle ACB, which is denoted by alpha as the angle at the circumference. And we have AOB as the angle at the center. Now, the theorem says that angle at the center, that is AOB, angle AOB, is twice the angle at the circumference, and that is 2 of the angle at the circumference. AOB is the angle at the center is equal to 2 of the angle at the circumference. Now, using the letters, now we're going to have beta is equal to 2 of alpha. Beta is equal to 2 of alpha, and that is for the A. Now, the same thing is applicable to B. It's the same theorem. It's the same theorem. So we have angle at center is twice angle at the circumference. So what is the angle at center? We have AOC, reflex angle AOC. You still remember what is reflex angle? Angle greater than 180 degrees. So we have, for case B, we have reflex angle AOC is equal to 2 of the angle, that is the one at the circumference, ABC. ABC. And using their letter, we have angle P is equal to 2 of angle Q. Angle P is equal to 2 of the angle Q. Now let's see example to illustrate the first point here. It said find the values of the missing angle in the diagram below. Find the values of the missing angles in the diagram below. And we have 3 missing angles. Angle P, angle M, and angle N. Now we're going by the first N because the N is relating to the theorem we have here in A. The angle at center label all the points. Then the angle at center, which is angle AOB. AOB. AOB is equal to the twice angle at the circumference. And that is 2 of ACB. AOB is twice the angle at the circumference, which is ACB. Then our angle AOB is what? 100. Which is 100 degrees. And angle ACB is what? N. Now, when you have something like this, in circle theorem, showing you're working like this is not complete until you state the reason. So, circle theorem deals with the reason why your result is so. So, we have to state the reason why we have 100 is equal to 2n. And that is to say, angle at center is 2 times angle at, so 100 degrees is equal to 2n. And the reason is that we have angle at center is 2 times angle at circumference. 2 times angle at circumference. So now we can find the unknown. That is, we divide both sides by 2. So we have this divided by 2.
No.
2n is equal to 100 degrees. So dividing both sides by 2. 2 will cancel 2 here. You are left with n. And 2 into 100, you will have 50 degrees. So your angle N is 50 degrees. Angle. Now the second case, which is that has to do with the theorem. A, O, B, and D has to do with theorem 2. Then we need to find P. But from the theorem, there is no how we look for P without knowing M. Now, to find P, we need to find M, which is the reflex angle of angle AOB. And comparing it with case 2 of the theorem, which is AOC, which is the angle C, is having relation with angle Q. So likewise, P is having relation with angle M. And looking at M, we see that it is at the center. Now, 100 degrees plus M gives you what? If you still recall, we have angle at a point is equals to what? 360 degrees. So you have 360. Now, just stating it or writing it out like this is incomplete. You need to give us the reason why it is so. So we have angle at equals to what? 360. So you have 100 degrees plus m is equals to 360. So we can find m from this problem now. So m is equals to, collecting like terms, we have 360 degrees minus 100 degrees. And here we'll have it as what? 360 degrees minus 100 degrees, you have 260 degrees. So our m is 260 degrees. And that has given us a clue to find P. And what is the same P? P is what? Angle at center is 2 of the angle at circumference. That is to say, m in degrees is equals to 2p in degrees. That is, angle at the center is 2 times angle at the center is 2 times angle at the circumference. And since we know that our m is what? 260. So we have 260 degrees is equals to 2p. 260 degrees is equals to 2p. Now, both sides by 2, we have 2 here, we'll cancel this 2. We're left with p. So 2 into 260. You have it as 130 degrees. So, therefore, our P equals 130 degrees. Theorem number 2. Angle in the same segment. Angle in the same segment. What is a segment? A segment is an area bounded by a chord and an arc. Now, the arc, as we all know, we have major and minor arc. Segment is an area bound by a chord and an arc. And as you can see, this is a chord, this is the arc. And looking at the two sides, you have two arcs. One is major and one is minor. So, the one with the major arc is known as the major segment, while the one with the small arc, which is the minor arc, is known as the minor segment. So, angle in the same segment is what we are going to be considering in this theorem. And we have two cases. Two cases. You can see from the diagram. Case A and case B. The theorem, it says that angles in the same segments are equal. Angles in the same segments are equal. Looking at the diagram for case A, B, and C, they are all angle in the same segment. A, B, and C here. That is angle A, angle B, and angle C. They are all angles in the same segment. So we can say that A is equals to B and is equals to what? C. A is equals to B and is equals to C. For the second case, that is case B, you can see that the diagram is in the smaller segment or the minor segment. And you have angle P and angle Q. So these two angles, by the theorem, they are also the same. So P is equals to Q. P is equals to Q. So let's treat one of the examples to prove the theorem. Find the values of the missing angle in the figure below. We have a circle with points P, Q, R, and S, P, Q, R, S, and T. And one of the angle is 40 degrees. And we said angles in the same segments are what? Are equal. So the solution to this problem now is that X is equals to what? Y and is equals to what? 40 degrees. Now, writing this has not proved your results, so you need to state the reason. So, what is the reason? Angles in the same segment. Let's look the next theorem. Angle in a semicircle. Angle in a semicircle. If you recall, semicircle is what? Dividing a circle into equal halves. So, any angle that is formed at the circumference of a semicircle is what we want to look at. Angle in a semicircle. Observe the diagram. This is a circle with center O. And this diameter dividing the circle into two halves. This is the angle at the circumference in both semicircles. Now, the theorem, it states that the angle in a semicircle is right angle. Is right angle. You can still recall what is right angle. An angle at 90 degrees. So when we say angle in a semicircle is right angle, we mean the angle in a semicircle is 90 degrees. So, looking at the diagram, angle ACB and angle ADB are the angle in a semicircle. So we have angle ACB, which is the same thing as angle ADB, is equals to what? 90 degrees. 90 degrees. So let's solve another example to show that theorem. Find the value of K and G in the diagram below. Find the value of K and G in the diagram below. Observe the diagram. PQR with center O, and the triangle PQR is a triangle that is formed at half of the circle. So the angle at Q now definitely is the angle in a semicircle. And we're given an angle which is NQR is 53 degrees. We have to look for K. We have to look for K. So, solution. PQR, that is the angle PQR, is what? Is 90 degrees. Why is it 90 degrees? Because it is the angle in what? A semicircle. So that is the reason. Angle in a semicircle has two values, which is K and what? 53 degrees. So angle PQR is K plus 53 degrees. K plus 53 degrees will also be equal to what? 90 degrees. So now we can look for the value of K. So therefore, K is equal to what? Connecting like terms, we have 90 degrees minus 53 degrees. 90 degrees minus 53 degrees gives you what? 37 degrees. 37 degrees. So the value of K here is 37 degrees. Now, I want to look for the value of G. If you look at the diagram, you see that you have two triangles. Triangle PQN, which is also a right angle triangle. Triangle PQN is a right angle triangle at N. Right angle triangle at N. So you have the value of K to be 37 degrees. The value of the angle N is what? 90 degrees. So it is easy to find the value of G. So we say in triangle PQN, that is, we're talking about PQN, the triangle involving G, K, and the what? The right angle at N. So from here, we know that sum of angles, if you recall, sum of angles in the triangle is what? Is 180 degrees. So we can say G degrees plus K plus 90 degrees all is equal to what? 180 degrees. And I said earlier that when you are talking about circle theorem, your reasons must be stated. So what is the reason why it is 180 degrees? Sum of angles in a triangle. And we know the value of K to be what? 37 degrees. So we have G degrees plus 37 degrees plus 90 degrees all equals to what? 180 degrees. So collecting like terms, we have G degrees is equal to 180 degrees minus 37 degrees minus 90 degrees. In degrees to be equal to what? 180 degrees minus 37 degrees minus 90 degrees. If you subtract the number from 180, you will have 53 degrees. So, therefore, G is equal to what? 53 degrees. That is the value for letter K and letter G. So far, we have been able to see the theorems, the angle at center and the angle at circumference, second theorem that has to do with segments, and the one with semicircle. Before we leave, I will be giving you some activity to carry out at home. Now hear the question. Find the values of the missing angles in the following diagrams. Find the values of the missing angles in the following diagrams. Diagram number 1, observe it. X, Y, Z, W, X, Y, Z. W, X, Y, Z are the points. Number 2, we have A, B, C, D, E, F. We have to look for the missing values. That is X, Y, V, W. And the third activity is ST. OPQST. We have two missing values. Two missing values. We have A and B. A and B. Hope to see the replies of this activity. Thank you very much. See you in the next lesson.